Hey YouTube, wanted to update you on how far I've gotten with this conversion. I've made a little bit of progress since my last video. Right now I have my X-axis up and running, although the wiring isn't permanent yet, but mechanically we're tied it up a bit, so let me just show you what I've done. And also I've adjusted my backlash with the backlash compensation, dialed in the lead screw to get that calibrated correctly, and got rid of my backlash, and I'd just like to show you where we're at with that. So in my last video I showed you this plate that I had previously designed and put onto the mill a couple of years ago, and I had forgotten what my plan was for that, but near as I can tell, those bolt holes that were in that plate that are 3/8 bolt holes are actually exactly in place for the stepper motors. Of course, they're a lot larger. 3/8 is way too large to put through a stepper motor, so what I actually did was use 3/8 bolts as standoffs and thread some M5s into the heads, screwed them in, and that works great. I probably could shorten them just a little bit to get my shaft and my motor in the coupler just a little bit further. But actually I can only go another 1/8 or 3/16 probably before it'll actually hit the shaft of the X-axis. So I really don't want to cut either one of the shafts at this point. And it's up and running, works fine the way it is. I could always put a set screw into the flat on the shaft of the motor if I think I'm going to get any slippage at all, but I've actually made some chips and there was no slippage or anything, so well, it wasn't heavy cutting. But so over here what I've done is I've set up my dial indicator to measure the travel of the table. When you ask Mach 3 to move 1 inch, how far it actually moves. For those of you who haven't done that process yet, if you want to dial something in really good, this works well. There's a setting in Mach 3. If you go to the settings tab and click that, and then go to set steps per unit right here, it'll ask you which axis you want to do, and I was doing X, so you click X, then you tell it how far you'd like Mach 3 to move the X-axis. And for me, I just use 1 inch. It's easy, and I'm canceling it now, but you put in 1 inch, and then you read on your indicator how far it actually traveled, and then it'll ask you how far did it actually travel. You type that number in, and it'll actually calibrate the steps per inch for your particular lead screw right down to like 10 decimal places. It's crazy. And usually I double check it after that, make sure it's the backlash didn't get mixed into the mix at all. That's one thing you need to do, is make sure your backlash is out of your screw. Make sure you're traveling in the same direction you're going to test, and all the backlash has been taken up before you do the calibration. And then once you've done that, you can go to config backlash, and you can see here that lead screw, that stock lead screw actually has 9 thousandths backlash, which is about what I thought it was actually. So let me show you what this will do. So right now I got it set on the 10, but I mean it's the same as setting it on 0. It doesn't matter where you start from. It's right on, as you can see, it's right on the 10. I'm going to ask it to move. I'm going to ask it to move 1 inch. So that should land right on the 10. Okay. And you can see where about a 1/2 thousandth over. Okay. So that's good. That's acceptable for me. I mean, especially with stock lead screws. Now the real trick though is when you go back, if it ends up back on the 10, or if it, because that's where you'd lose your backlash will come into play. So we're going to move back and see where we end up. Moving back 1 inch. And right where we started. So, you know, I can't complain about that for stock lead screws. And for what I'm using for a setup here. You know, to be a 1/2 thousandth off in one direction, but come right back to where you started from to begin with, I think that's definitely acceptable. I'll do it one more time just to demonstrate that it's repeatable. And again, we end up with a 1/2 thousandth over. I don't know if my lead screw isn't quite calibrated absolutely perfectly, you know, but it's, like I say, it's close enough for what we're doing here. And right back to where we started. So, you know, to me that's fine. I don't know if you can hear the backlash get taken up when I first move the machine. If you listen really carefully, you can hear it taking up the backlash. You hear that thud? That's the backlash. That's 9 thousandths of backlash. Yep. Here comes a big thud. There it is. So I've also got my YAxis. Got the coupler mounted. This axis is a little bit trickier because the thrust bearing that keeps the lead screw from pulling in or pushing out rather than the table moving, the thrust bearings are in this portion right here. When I did my x-axis, I chose to mount things on this end because there's no thrust washers on this end. There's just a bearing. All the thrust washers are in this end. So I left that end stock. Put my motor on that end, so the thrust wasn't an issue with the x-axis. With this one it was. I actually ended up threading the lead screw shaft and putting a nut to lock the thrust bearings to be able to tighten up on them, take up, you know, the slack, so they're just snug. And then I also threaded this coupler, which I wasn't planning to, but I ended up threading this coupler and actually gib is locked here. And I actually put in a set screw that goes right in. I mean, it's kind of a it's a custom arrangement that, you know, it works for me for now. What I did was the keyway that's in the shaft, I actually threaded that coupler, tightened it up nice and snug against the other nut, and then actually marked where that keyway in the shaft was and threaded an M4 down into that keyway. So this thing is locked right into the keyway. And we're tight Our thrust bearings are tight, snug, just the way they should be. This is the backlash on this axis, which truthfully it's about the same as the stock one. If you look here, oh, I can't. This one's actually locked up with the X. I'll unplug that motor. So that's the backlash. Actually, it feels like this one has more backlash. It's probably because the wheel's bigger. It feels like more than this one. But I imagine it's about the same, because if you were to actually set this, yeah, that comes to about 2, 4, 6, 7. It's calling that 7, but I bet you we're going to be in the neighborhood of 9 on this one also, 8 or 9 probably. So yeah, that's where I'm at. I haven't done any more up on top, other than I've made my drawings. Basically gonna, on the Z-axis, I'm gonna basically do virtually the same thing as I did on the X. I'm gonna make a plate that bolts. Apparently I had to drill these holes into my machine. Apparently this is something I did. I don't remember doing that. That was a couple of years ago. But on the Z, there is 4 holes up there already that hold that cap on. So I removed the cap, and I'll use those 4 holes to bolt a plate on, and then I'll do the same thing I did with I'll do some bolts for standoffs, tap some M5s into the top of them like I did here, and run it like that. It'll be a good start. This Y-axis is going to be trickier. This is going to be a little bit more involved, because it's not a flat surface. You get this bearing assembly to contend with. Plus, the big thing is your saddle travels out beyond the end of this, so it can't. Whatever I use can't stick up beyond here. And the thing of it is, the motor will be about here. So the motor does stick up, but the part that mounts against the machine can't. So it's going to have to come out and then have a plate that sticks up to mount the machine, mount the NEMA 23. So that will be a little bit trickier, but certainly not too bad. It's certainly doable. Again, I'm just trying to do this simply and cheaply to get myself up and running. So, and then maybe from there, once I have a CNC mill, maybe I can make some of them fancy things that you buy on eBay. And probably not. I'll probably just buy a set of lead screws that are all ready to go with the motor mounts and everything. It just makes sense. But all right, that's it for today, or at least for this video. Thanks for watching. Hope you enjoyed it.